activity 3, which is a graphics transformation under chapter 3. Graphics transformation, basic transformation, transition, rotation, scaling. Combining transformation for complex movements, and introduction to advanced transformations perspective. So, basic for transformations. Transformations play a very important role in manipulating objects on the screen. It should be noted that here the algorithms will be implemented in code, and the built-in functions will not be used to give a good understanding of how the algorithms works. Also note that all transformations are implemented in 2D. So there are three basic kinds of transformations in computer graphics, which is translation, rotation, and scaling. Translation refers to moving an object to a different position on the screen. The box on the lower part, which is the where tx and ty are translation coordinates. The OpenGL function is GL translate. So rotation refers to rotating a point. Example, which is in the box. Scaling refers to the zooming in and out an object on different scales across axes. Combining transformation for complex movements. As with the OpenGL order of transformations, when combining these homogeneous representation matrices to produce compound movements involving translation, scaling, and rotation, the matrices are presented in reverse order. For example, to transform a point by 3, 4, 5, rotate it around the x-axis by 45 degrees, and then scale it by 0.3 in all directions. The matrix multiplication is as follows. So note how the translation matrix of the first operation is placed on the right and the scaling matrix on the left. To multiply this out, we begin by multiplying the last two matrices, the translation and rotation, to get the following. So then we complete the multiplication with the remaining two matrices, which is result in the following. Introduction to advanced transformation perspective. So perspective transformation, in general terms, perspective means when human eyes see an object, it looks bigger when it is close to the eye and smaller when it is far from the eyes. Transformation means the transfer of an object from one state to another. Perspective transformation works in the same principle in which human vision and camera work, that is, the conversion of the 3D world into a 2D image. So, frame reference. A frame of reference consists of an abstract coordinate system and set of reference points which fix the coordinate system and measurements. To define a reference frame, only n+1 reference points is needed. Using rectangular coordinates, frame is defined with a reference point from the origin, each at 1 unit distance in n coordinate axis. Frame reference. A frame of reference consists of an abstract coordinate system and set of reference points which fix the coordinate system and measurements. To define a reference frame, only n+1 reference point is needed. Using rectangular coordinates, frame is defined with a reference point from the origin. Each one is unit distance in n coordinate axis. 5 frames of reference. 1 object coordinate frame. It is used for modeling object. Word coordinate frame. It is used for correlating the objects in a 3D world. Camera coordinate frame. It relates the object with the camera. Image coordinate frame. It is not a 3D coordinate system. It is used to map 3D points in a 2D image plane. And last, pixel coordinate frame. It is also not a 3D coordinate system. In this, each pixel has a value for coordinates. So thank you. That's it.